Okay, so in this video we will discuss about the modeling, or we can say that designing of atom, that how atom is designed. We have to find the position of electron, that where electrons are placed in an atom. So as we know that atom is divided in two theories. First one and second one. First one was given by Dalton. Okay, and the second one was given by a group of scientists, we can say, because many scientists were there. Dalton gave the theory that atom cannot be divisible. Indivisible particle means it cannot be divisible furthermore into subatomic particle. But the group of scientists said gave a concept of divisible particle, that atom can be dividable more further in subatomic particle, which are proton, neutron, electron, neutrino, and etc. Many more, 100 particles into subatomic particles are total 100 particles. So basically a group of scientists came and determined the position of electron. Firstly, J.J. Thomson was the first scientist who we can say the design or model or we can say the atomic model of electron. That he found the position of electron. He says that the scientist was J.J. Thomson. He did an experiment called as plum pugging. Okay, in this we can say the experiment, he take a basically he was eating a watermelon and says that the red part of watermelon can be considered as a proton. This is a shape of watermelon. The red part is considered as a proton, and the black seeds inside it can be considered as an electron. And this theory was given by J.J. Thomson, and this is called the plum pugging. He says there is a plate in which electrons are not moving, they are in a static form, means they are not moving. Here are the positive charge, mean we can say the red part of the watermelon, and here some seeds, black seeds, are the electron which are calm and quiet. Okay, this was a basically theory given by the J.J. Thomson. The second scientist was Rutherford. What Rutherford said? Basically, Rutherford did an experiment. What he did? He says electron move in a spiral motion. What is now spiral motion? Means this is electron moving in a spiral motion. In this type. And when it will move in this position, as we have discussed earlier, that when electron is moving in a spiral motion, or we can say means anytime electron is moving, when electron moves it release some energy, and when energy is decreasing, then the electron must be fall in the nucleus, because the size of atoms will be decreasing more and more. So the Rutherford only give the concept of spiral motion, that electron move in a spiral motion. Now the third scientist was Bohr. Bohr was a student of Rutherford. Rutherford was his teacher, we can say. What actually Bohr said? Bohr said that electron move in a circular motion. In this way, this is the nucleus, and electron move in a circular motion, or we can say now orbit. The concept of orbit was given by Bohr, and he says that electron does not move in a spiral motion, it moves in a circular motion. Then a fourth scientist came and named as Heisenberg. He rejected the theory of Bohr, because when he did the experiment, that he take a microscope and take one atom of any substance, any element. He just put a photon rays in it, and as we know that when we give energy to any electron or any atom, the the electrons of atom will be excited and move to the upper shell. As Heisenberg did the experiment, and he said that when I did the experiment, I didn't found the position of electron. Actually, he didn't found the momentum and position. Both he didn't found anything, and he said that he challenged the board that how you are saying that electron move in a orbit motion, or we can say the circular motion. So the theory of Bohr was cancelled by Heisenberg. Heisenberg cancelled the theory of Bohr. Okay. Now the fifth scientist came, named as quantum, or we can say the Max Planck. What he did, or what he says that he actually gave the concept of spinning motion. Now what is spinning motion? He says that electron neither move in a spiral motion, neither in a circular motion. Electron move in a spinning motion. Now what is spinning motion? Means electron move in his own axis, like this. For example, this is the nucleus, and this is the shell. For example, this is the K shell. K shell only contain 2 electrons in it, for it is because it has a storage of only 2 electrons. So he says that electron only move in a spinning motion. Spinning motion is a is always over axis, over one axis. That electron revolve in its own axis, not in a circular motion, neither in a spiral motion. And here we can say that K shell contain 2 electron. So he gave the concept of clockwise and anti-clockwise. What he said that if there are for suppose that K shell contain 2 electrons, one electron will move in a anti-clockwise, and one will move in a clockwise. Now we have studied in maths that clockwise is always negative and anti-clockwise is always positive. So one electron will move in a anti-clockwise, means positive, and one electron will move in a clockwise, means negative, in a negative. It will move here, it will move here, so it will not repel each other, because as we know that like same sign repel each other. They will not repel because one is moving in a clockwise direction and second one is moving in the anti-clockwise, so they can't be they can't attract each other, they can't repel each other. Okay, so in this K shell contain 2 electron. These 2 are means can be called as we can say that it is the orbital. One pair of electron means there is a pair of electrons, so we can say that the one pair of electron is called the orbital. He give the concept of orbital. Bohr only give the concept of orbit, that electron move in only circular path in a circle. But what is the orbital? Orbital motion is always on every axis, means x, y, z. It is on every axis. Okay, so this was all about the today's lecture, how we have find the position of electron, that how electrons are moving and in which position they are, how they are behaving, these all properties and all that. Okay, and one thing important, as we know that clockwise move in a means this is a circle. Okay, when we move in this side, it means and clockwise, because our watch move in this side, so it is always negative. And if the one thing is moving in a anti-clockwise, means positive, so the angle, you can say the arrow, so clockwise is determined as in this direction, it is coming there, so in this This is the clockwise and this is the anti-clockwise. This is representing this is a symbol by which we can represent the pair of electron in an orbital. That this is the clockwise and this is the anti-clockwise. This is a symbol that how we can represent the a pair of electron in an atom. Okay, this was all about today's lecture, and we will discuss furthermore this J.J. Thomson was just a first scientist, and he considered the position of electron in such a way that he was eating a watermelon, and he just actually says that the red part can be called as protons, and the black seeds can be called as electron, and they are calm and quiet. They cannot move, they are stable, and all about that. Okay,